Hey folks, welcome back to another video. Today we're looking at question 19, remove end node from end list. The way we'll be approaching this problem is by using two pointers, a slow pointer and a fast pointer. So let's jump right in. So the first thing that you need to do is to create a list node called dummy. And the reason why we're doing that is because we want to have multiple access points to the head node. So we'll have a dummy node, and let's just initialize that as a new list node. And the next node of dummy would be the head. So this way we can access the head node as many times as we want without reassigning it. And we need two nodes after. We need the fast node, and then we need the slow node. Both of them are assigned as dummy, and you need another variable. Let's call it I, and just initialize that to 0. The first thing that we need to do is we need to keep incrementing I, and we need to keep doing that till it hits k. And what you're doing within the for loop is in the while loop is that you keep saying, hey, the fast list node, just keep moving one step forward till we hit k nodes. So this particular node, fast node, will be k steps from the start. But what do we need? We need the kth node from the end. That's the reason we have fast and slow. So once we have something pointing towards the kth node from the start, what we need to do is we need to move the fast node and the slow node at the same time. So as soon as the fast node hits null, we know that the slow node is at the kth place from the end. What does that mean? So what exactly does that mean? It means that since there's a difference of k nodes between slow and fast, as soon as the fast node hits the end of the tail, the slow node is k nodes behind the fast node. So the slow node will be pointing towards the kth node from the end. So that's the reason why we had to do this part right here. Awesome. So let's just do that. So as long as the fast node is not equal to null, you keep moving the fast node, and the slow node will keep moving along with it. As soon as the fast node is null, as in it's at the end of the linked list, and we have the slow node pointing towards the kth last node from the end. So what we need to do is we need to delete that node. So how do we do that? The next node that we're looking at, it will just point towards the next node. So that takes care of the part of just eliminating the node that we want to remove. And in the end, you just want to return the head. So you just return this as dummy.next. Perfect. So let's quickly compile this and see if it's okay. And my bad. Okay, cool. Let's compile this and see if it's okay. Awesome. So the first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution is of n, since we have to iterate through every single list node, and the space complexity is of 1, since we're not really using any additional space to do the computation. Awesome. So that's the solution for this problem. Please let me know if you have any questions in the comments below, and don't forget to subscribe. I really appreciate that, and see you all in the next video. Peace.